AI is seemingly everywhere. One thing is for certain, and that is when AI servers are training across a switched network fabric, the traffic patterns are unlike anything generated by humans. The traffic is different, and thus the testing needs to be different. And that is our topic today. And we are happy to have an expert with us from Keysight, Avik Bhattacharya, to unravel some of those mysteries for you. Avik, welcome. So let's start. Could you briefly introduce yourself and describe your current role at Keysight?
Hey, thank you, Kevin. I'm a senior product manager at Keysight, and I'm responsible for our network infrastructure test product line. As part of this role, I am working with every player who is involved in the AI ecosystem, starting from the chipset vendors, the network equipment manufacturers, all the way up to the hyperscalers, who are deploying AI or in some way or the other contributing to the AI ecosystem. So it's a very challenging and exciting job, and we are enjoying it a lot.
I'll say. So, obvious question here: how is artificial intelligence changing the technology landscape of networking in today's world?
Yeah. I mean, AI is really pushing our networks to the edge, right? And we are talking about trillions parameter models, millions of GPUs working in parallel. And there are upgrade cycles which just don't stop. I mean, it's relentless, right? So LLMs are completely transforming the AI and cloud services, and the training which is going on isn't like it's the normal average workload, like you said, Kevin. It requires these massive distributed clusters made up of tens of thousands of GPUs to communicate with each other, and that scale introduces a whole new set of challenges when it comes to data center network design. I mean, I'll take a few examples, right? One of the big ones is the traffic pattern. The LLM training doesn't behave like traditional cloud workloads. We see a lot of elephant flows, huge data transfer with low entropy, and traffic can be really bursty. That unpredictability makes it very tough to manage. And then at the same time, there is multi-tenant environments and parallel training jobs running side by side, and these jobs all compete for shared network infrastructure. And if you don't manage them carefully, then the performance can take a big hit, right? Now, this is on the network side. Very interestingly, also on the server side, the NIC, which is a very important piece of this whole puzzle, the NIC's capacity is another big one, right? Your network interface cards have to be smart enough, and they have to handle congestion so that they can make the best use of the available bandwidth. There are a lot of innovation happening in that space.
Okay.
Right. So, and finally, Kevin, maybe just one more point, right? The LLM training is a very highly fault sensitive matter, and when I say fault sensitive, it's synchronous. So all the GPUs need to finish their interaction for each of the iteration, right? If one GPU has an issue, then whether it's because of the hardware, whether it's because of the network, it can delay the entire training process, and that's the level of fragility that we are dealing with when we are talking about AI fabrics.
Sure. Which brings us to bottlenecks. You've already talked about several of them. You could have bottlenecks in the server, in the NIC, in the fabric, or I mean, there's a lot of different places where you can have bottlenecks, and they can have very significant negative impacts on job completion time, right? Which is a totally different thing. We're used to thinking in frames per second, packets per second, bits per second, but now job completion time, things like that are major importance to AI, LLM type of situation. So are there other bottlenecks that I haven't mentioned that people should be aware of?
Yeah, no, I think you kind of mentioned the peak of the pyramid here. If I take a step back a little bit, right? So when you are dealing with large GPU clusters for training, the scale of that data exchange is massive, right? And these GPUs constantly need to talk to each other. That turns the network into the real bottleneck, as you mentioned, right? The fabric has to be lossless. Any packet drop, can derail the performance and increase the training time because it needs to be rerun again. So it is essentially, these multiple of these GPUs trying to exchange information simultaneously. You get microburst, sudden spike in the traffic, and that can cause serious network congestion. That is where a real complexity lies, right? Making sure the infrastructure can handle those bursts without missing a bit, right? Now, the other point, which is very important here, in order to handle the network congestion at scale, we rely on quite a few mix of technologies. We have priority-based flow control or PFC. We have congestion control mechanisms like DCQCN over Rocky V2, right? But the point to remember is that these tools, while they do very well controlling the congestion, by design they introduce latency because they control congestion by slowing down the network.
Sure.
So it actually becomes a balancing act, right? You need multiple rounds of benchmarking and fine tuning to really find out what is that optimal network configuration that works.
Right. Okay, Avik, you've been talking about the bottlenecks. There's lots of them. How does Keysight help in addressing these challenges?
Yeah. I mean, at Keysight, we are just not observing the AI revolution like it's happening everywhere. We are trying to enable it, right? So as the AI workloads become more complex and performance critical, the infrastructure behind them needs to keep up, and that's where we come in, right? So we are delivering advanced testing and validation solution tailored specifically for AI, right? Helping our customers build their networks, the systems that are scalable, efficient, and resilient. And whether it's optimizing the training throughput or validating the data path or even securing an AI driven application, our tools try to ensure that the AI works are, they work as it's intended to work in a real world.
Okay. The idea being that your tools can feed real world flows into the network to model it accurately so that when the actual flows go into it, it's going to behave the same way.
Right.
Which
Yeah.
key. And you mentioned security. So with AI applications becoming part of everyday life, how does the network security landscape change?
Yes, AI security, and more specifically, I would say large language model security, right? It's a real and growing risk everywhere
Yep.
as the LLMs become like deeply integrated into business operation or critical systems, right? They introduce new attack surface, and new attack surface means new vulnerabilities,
Right.
and these needs to be taken very seriously. So for example, attackers nowadays can craft malicious input or what is also known as prompts that manipulate the model into revealing sensitive data or even like bypassing safety filters or performing unintended actions. So this is called the prompt injection attack. And there are, in order to prevent this, there are AI security gateways, which are like the new kid on the block, and they sit between applications and the LLM model these applications are using. So inspecting all the prompt requests that are sent to the LLM and their responses, and working to prevent prompt injection attempts and malicious or unintended LLM outputs.
Okay, good. So then with that, for someone who's not familiar with what your offerings are with AI, could you describe some of the core offerings of the product line and how AI testing fits into your overall product portfolio and or verticals that you serve?
Yeah. I mean, it's going to be a long answer, so bear with me
Okay.
a little bit because Keysight is plugged into multiple building blocks of AI. So we deliver advanced testing and validation solutions tailored specifically for AI, as I was talking about just in a while. We have multiple solutions that caters to the different areas of these challenges. So the first is the Keysight AI collective benchmark application that performs micro benchmarking on a distributed communication algorithm, or the what is also known as the collective communication that I talked about a little while back. The primary goal of using the collective benchmarks app is to ensure that network consistently delivers optimal bandwidth across various data exchange patterns expected in distributed AI jobs.
Okay.
On the other hand, we have something called the Keysight AI workload emulation that replaces short sequence of mimicked AI, real AI training workload behavior, right? So it is like repeated over thousands or even millions of iterations, known as epochs in this world. And these workloads are typically a sequence of compute and communication tasks, and which is shaped by the specific model partitioning schema that's used, or the job that is at hand for between those thousands of GPUs. So the workload emulation app allows the users to evaluate the performance impact of different partitioning choices across various networking topologies. This is mostly on the training side, right? On the other hand, inference workloads, right? They serve in real time to end user applications. And unlike training, which focuses on throughput, inference demands the ability to deliver consistent, low latency responses at scale and supporting a large number of concurrent connections, right? So it is essential for validating those. Inference often runs alongside inline security tools. We were talking about the firewalls just a little while back. So with Keysight's CyPerf solution, we can deploy agents across all the applicable compute nodes and endpoints, whether that's in public cloud environment or traditional data centers or colos. Once those agents are up and running, they can generate real world traffic and assess how the network is performing. Similarly, for the firewall and the security piece, the CyPerf's AI/ML emulation also creates this prompt injection attack that we were talking about. They can monitor and inspect the gateway's performance with respect to its security efficacy.
Okay. So what you're talking about then is, for people who might not be that familiar with AI yet, when you're looking at the training, that's more east-west type of traffic, right? And the inference is more the north-south, coming from the outside into the models that we're actually running and getting the value out of the models. Is that oversimplified, or is that more or less accurate?
No, you're spot on, Kevin. Basically, every deployment has a backend network, a front-end network. The backend network mostly takes care of the training, where all the heavy lifting job happens, whereas the front-end network, which caters to the which you referred as the connections coming in from outside of the data center, which caters to the clients who are really using these applications.
Okay, good. Right. So everybody sees that AI is moving so fast, it's hard to keep up with it. So can you talk a little bit about Keysight's product timeline, and with respect to AI and how it's addressing where you see things are going and when?
Yeah. No, that's a great question. So all the solutions that I just talked about for the benchmarking, the training, testing the scale of the front end network, and also the security piece, these are already released and being used by our customers. When I say customers, they span from different vendors like the chipset vendors, the switch vendor, the NIC vendor, the server vendors, and eventually hyperscalers, or somebody who is actually deploying the AI data center, right? So these are already released products and being used, but AI is an evolving space, right? We are moving very fast from InfiniBand to Ethernet using Rocky V2 as a transport, and as we speak, there are already discussions about, for example, Ultra Ethernet Consortium is talking about next generation transport for AI. So we are plugged into these discussions and contributing to the next generation of test methods already. As these technologies evolve, we expect our Keysight solutions to also start supporting the new test methodologies. On the other hand, this is about transport. On the other hand, if we look at how the trainings collective communications are evolving, and there could be new collectives, there could be newer workloads coming into the play for different training models, or there could be new load balancing algorithm, right? So AI is a journey. We at Keysight are enjoying this journey along with our partners, and we are trying to plug in new test methodologies to cater to all of these new things that are happening in the space.
Yep, good, excellent stuff. So where can readers go to find out more about your offerings?
Yeah, I would say the one-stop shop is the Keysight's website, www.keysight.com, and search for Keysight AI, which we also call lovingly as KAI or Kai. Okay.
Okay.
And there is an URL in the video which Kevin will help, access.
Okay, terrific. All right, thanks, Avik, and thanks everyone for joining us today.
Thank you, Kevin.